Good morning, everyone. Good to see you. I hope you're enjoying SQL Bits already. Who is attending SQL Bits for the first time? Wow, lucky you. No, really, I love SQL Bits. It's my favorite event, community event in the world. You're going to have a lot of good time. Make sure you go to the party tonight. Don't miss the party, okay? Remember I told you that. Okay, and thank you for choosing to spend the first session of the day with me. I don't know why you did that, but that's your choice. So I hope you have a good time here as well. A few words about me. So my name is Guy. I'm a data platform MVP. I am also the CEO and founder of Madeira Data Solutions. We provide all kinds of services and solutions to customers around the Microsoft data platform, which is SQL Server, but a lot of other things as well. I'm also one of the leaders of the Israeli data platform community. We have a large, wonderful community, thousands of people. We do a lot of activities, meetups, forums, and stuff. I want to just mention two things that you might be interested, if you're not aware of them already. One of them is the SQL Server Radio, which is a podcast that I do together with Eitan Blumin. Once a month, we have a show about SQL Server, anything around SQL Server, new features, projects. We interview some people here and there. So sqlserver.radio.com. And the other one is an open source repository on GitHub. It's called Madeira Toolbox. We upload scripts and stuff on a daily basis, lots of useful stuff you can use for free. So make sure you have that as well, Madeira Toolbox. You can search Madeira Toolbox or SQL Server Radio, you'll find it. Two more important things. One of them on the left is to download all the session materials. I'm going to show you lots of scripts today. You can download everything, the slide deck and all the scripts from the left one, okay? And the right one is, of course, the session feedback. Very, very important for me and also to you for future sessions. Please provide me feedback, not now, at the end of the session. So, we are here to talk about the most important performance factor in SQL Server and also Azure SQL. And I know that you really want to know what it is, okay? So I'm going to tell you. It's statistics. Thank you. No, really? No, I'm kidding. Okay. So, let's talk about statistics in SQL Server. I have a question for you. What is the largest library in the world? It's that, by the way. You know? No? Exactly. Thank you. The Library of Congress, Washington, D.C. If you haven't been there already, go and visit the Library of the Congress. It's really impressive. They have approximately 800,000 miles, 800 miles of bookshelves, and approximately 160 million items, out of them 40 million books, more or less. Quite impressive collection. And let's say that you are here in the middle, okay, now everything is bookshelves, right, a few floors. You are right here, and let's assume that all the books are organized, they are ordered by the ISBN. It's like a universal catalog number of books, okay? So they are ordered ISBN. Doesn't tell me anything, but they're ordered this way. And I want to search for all the, let's say, fantasy books, okay? We want to find all the fantasy books. I don't know how many fantasy books are out there, out of 40 million, okay? But we want to find them. So we need a plan. One plan is to do this. We will just go book by book and check whether it's fantasy or not. If it's not fantasy, we'll put it back on the shelf. If it is, I'm going to take it, okay? And this would be a clustered index scan, right? That's one plan. Another plan, it will take some time. There's another option. Let's say that there is a terminal right here in the middle where I can search for a specific book category, like fantasy books. And it will give me all the locations, the list of all the locations in the library with fantasy books, okay? And then I can take each location, go find that specific book. To make it more interesting, let's say we don't have a smartphone or a tablet, we can't print it, it's only on the terminal in the center of the library, and you can only memorize one location at a time, okay? So it's going to look something like this. Take the first location, go find a book, go back, second location, go find it, go back, and so on, okay? That's another plan. That would be a non-clustered index seek plus key lookups, right? Now, if there are only 3 fantasy books in the library, that's a much, much better plan than the previous one. But what if there are 10 million fantasy books out of 40 million? That would be a much, much worse plan than the previous one, okay? And in order to decide which plan to use, we need to evaluate, to estimate somehow how many fantasy books are in the library. It doesn't have to be accurate. We just need to know more or less, whether it's around 10, 100, 1,000, or 10 million, okay? And based on this more or less value, we can decide which plan is better. And this is what SQL Server needs to do on a daily basis, okay? For each and every query, based on statistics, it needs to evaluate and decide which plan is better. And in many, many cases, it will be okay, it will get the right choice. In many, many other cases, it will take the wrong choice, and you will suffer from poor performance. And I want to show you some examples for that. So let's see a demo. It's demo time. I have lots of stuff to show you. So let's hope we have enough time for everything. By the way, if you have questions, use the application or raise your hand, whatever is better for you. I'd love to have questions along the way. Whenever I troubleshoot performance, query performance, I always use two basic things, at least two basic things. One of them is set statistics IO on. Gives me some statistics about IO, which is very important. The other one, of course, is include the actual execution plan. I'm using SQL Server 2022. Most of the things, almost everything I will show you today is also available in Azure SQL, whether it's Azure SQL Database, Managed Instance, same. But there are many, many differences between the versions of SQL Server. I will mention them along the way, because I'm sure some of you might be using SQL Server 2019, 17, 16, 14, maybe 12, I don't know. So you should know the differences. OK, so we see we have the library books table. Currently, it's a heap. We're starting from scratch. It has no indexes. It also has no statistics at all. OK? And I'm going to show you an example of how the data looks like. So here it is. Here's the ISBN, the title, the author, the category, like mystery, plays, publication date, number of pages. By the way, I took some real titles and author names, but I mixed them together. So don't try to look for logic in the data, OK? It's all made up. If we search for the count, then we can see we have more than 40 million, around 41 million books in this library, in this table. And I want to look at the histogram, how many books we have per category. Okay, so we group by category, and I create a histogram. So as you can see, for some book categories, we have, let's say, classics. Again, doesn't make sense. Around 8,000 books. But for example, for romance, we have more than 5 million books. Okay, so for some categories, we have a few books. For some, we have many, many books. Now, let's ask SQL Server how many classics we have. Okay, so now SQL Server, for this query with the where clause, it needs to evaluate, again, potentially based on statistics, how many classics we have more or less, and based on that, it's going to derive a plan. It's important to understand that whenever you execute a query, SQL Server first needs to compile the query, and during compilation time, it needs to use statistics to come up with estimations and generate the best plan possible, and only then it begins runtime, running the execution plan. Okay? So whatever is available for SQL Server at compile time, this is what's going to impact the plan. So we know that we have almost 8,000 books. If we look at the plan, now the most important thing I want to look at the plan is this. So we have a table scan on the books table, and the two numbers you see here, 7734 is the actual number of books. 6450 is the estimated number of books. This is the estimation that SQL Server came up with during compilation time. In a few seconds, I'll show you where it comes from. Okay? But it's very important. And here's a big tip for you. Whenever you troubleshoot execution plans, you want to analyze a plan and understand what's the problem, where is the bottleneck in terms of performance. Search for the gaps between the estimated and the actual number of rows. This is the most important thing, because in most cases, the reason for poor performance is because the SQL Server was wrong. For some reason, it estimated the wrong number, and then it came up with the wrong plan. You need to find where in the plan it got things wrong. Then, of course, you need to understand why and solve the problem. Okay? A lot of people, when they analyze plans, they look at the cost. Don't do that. Don't look at the cost, because the cost is based on estimated values. Always. Even when you look at the actual plan, the cost is always estimated. And if SQL Server got things wrong, it's a wrong estimation, then the cost is also wrong. It's misleading. Okay? So I've seen many, many times people look at the wrong operator in the plan because it says 99%, and they spend a lot of time trying to improve it, but this is not the problem. The problem is there, somewhere else. Okay? Remember that. So SQL Server estimated 6,450 rows. Not too bad, not too far from the actual value. I will show you later where it came from. What happens if we ask for Romans? We know that there are more than 5 million books. This is the results, but look at this. Oops. It's the same estimation. SQL Server still estimates the same value. Even though it's a different query, it knows we are asking for Romans books, but it comes up with the same estimation. So what's happening here is that at this point, SQL Server still doesn't have any statistics. And I know it might be a surprise for some of you. If we do a refresh, there's still nothing. So what happens? How can SQL Server estimate anything without statistics, without knowing anything about the table? So in this case, SQL Server has some rules. One of the rules, if we don't have statistics, it has to assume something about the distribution of the data in the category column. And the assumption is it's a square root of the total count. So we have 41 million books. Square root of that is going to be a familiar number. Okay? This is the estimation made by SQL Server. So it estimates there are 450 distinct categories. Within each category, there is the exact same value of rows. Okay? To make it more simple, if you have a table with 100 rows, it will always estimate that there are 10 distinct values. With each one, there are 10 rows. Okay? Square root. And of course, it has nothing to do with the actual values, just a wild guess. And in many, many cases, like in the previous execution plan, you would suffer from poor performance. Okay, so we want to allow SQL Server to have statistics. And I cheated a little bit. If we go to properties of the database, and we go to options, then we have a bunch of properties you might be aware of. One of them is auto-create statistics. By default, it's true. I set it to false for the sake of the demo, of this demo. Usually it's true. You should leave it as true in most cases. Okay? And this means that whenever SQL Server encounters a query where you filter on a column, like in our case, on the category column for the first time, and it still doesn't have statistics, it will automatically create statistics as part of the query compilation. Okay? It didn't do that in this case because I turned it off. We will turn it on in a second. We also have auto-update statistics, which we'll talk about later. This is also true by default. And in this case, sometimes you want to leave it as true, sometimes not. I will talk about that later. But let's start with the auto-create. Let's change it back to on. Auto-database, set auto-create statistics on. And now, I'm going to run the same query with Romans, with 5 million books. And look. Suddenly, SQL Server knows, more or less, how many books are in there, because during compilation time of this query, it also created statistics very, very fast. It's impressive. Okay? It already has statistics now on the category, and it used it already during compilation to generate a better plan for this query and get much better performance. There are all kinds of ways to look at the metadata about statistics. I'm going to use a combination of a few DMVs and catalog views, cstats columns, DMDB stats properties, and so on. Not going to get into all the details. You have the scripts. You can download them later. I'm going to create a function, an inline function, with the object ID parameter, so I can easily retrieve metadata about statistics for a specific table. And here it is. I'm going to look for statistics on the library books. So right now, we have a single statistics object on this table. It has stats ID 2. It starts from 2 because 1 is always reserved for the clustered index. I'll show you later. We still don't have a clustered index at this point. This is a generated name, system name, for automatically created statistics. It looks like this. It's on the category column. It's a column statistics as opposed to index statistics. Again, I'll show you that later. It was auto-created. It wasn't user-created. Last updated now. This is the number of rows it is based on, 41 million. And this is the rows sample. This is important. SQL Server, when it automatically creates or updates statistics, it uses a sample rate, a very small sample of the table, to generate the distribution based on that. It doesn't do a full scan in most cases, depending on the side of the table. And this percentage, in this case, it was 0.7%. It is based on the size of the table. The more the table is bigger, you will have a lower percentage. Okay? In this case, it was only 0.7%. And it's quite impressive because based on this very small sample, it managed to estimate pretty well the number of romance books, 5 million. Okay? We also have the number of steps. This is the number of entries in the histogram. I will show you that in a second. Okay? It is limited to 200. SQL Server can only have up to 200 entries in a single histogram. That's not a lot. If you have a table like 1 billion rows, SQL Server still needs to come up with a distribution based on a very, very small histogram with only up to 200 entries. In this case, SQL Server could use only 26. Doesn't need more than that. I will talk about the modification counter later. Let's look at the histogram, the statistics itself. So we have a command, dbc show statistics. The first parameter is the table name. The second one can be a column name, if you haven't automatically created statistics for that column, or a statistics name, if I'm using a specific statistics. In this case, we're going to look at the category. And dbc show statistics returns 3 result sets. The first one at the top is like a header. It's similar to the information I just showed you. Okay? I will jump to the third one. This is the actual histogram. The SQL Server created a histogram based on the sample of data from the category column. In this case, the histogram is very, very simple because it only has 26 distinct values, distinct book categories. So it said, OK, I can simply take each one of them, put them at a separate entry in the histogram, and estimate, this is an estimation based on the sample, the number of rows in each category. Okay? This is the histogram. This is how it looks like. Very simple. And this is how SQL Server managed to come up with the estimation for the romance books. It comes from here. Okay? Very simple. The other one, the all density value, this one is interesting. This tells SQL Server what is the average number of rows per distinct value in the entire table. And sometimes this is important. The best way to demonstrate it or to explain it is to take this value. Let's put it here. Oops. This one. And I'm going to multiply it by the number of rows on which the statistics is based, like this. 1.6 million or so, right? Let's put it here. Remember this number. Okay? This is the average number of rows per category in the entire table. Sometimes SQL Server needs this number. I will show you that later. Okay? Another way to look at the histogram is through a DMV or a DMF. DMDB stats histogram. You give it the object ID and the stats ID. In our case, it's 2. And then you can get only the histogram in a result set, which is much more flexible because you're using a DMV, a select statement. You can join it to other things, filter, group by, and so on and so on. So it's more comfortable than doing dbc check, show statistics. Sorry. OK. Let's create a bunch of indexes. So I'm creating the clustered index on the ISBN, just like with our story, and then a non-clustered index on the category. It will take like 2 to 3 minutes, and while it's running, I want to tell you a few things. So why is it so important to have good statistics? What does it affect? Okay, so it's not just, okay, yes, it's the estimated number of rows, but why is it important? There are many, many, many things when the optimizer needs to decide how to come up with a plan that rely on this estimation. One of them, which is what I'm going to demonstrate, is the decision between a scan and a seek plus lookups. Okay, we're going to see that in a minute. Another thing, for example, is joins. If SQL Server thinks that one of the tables has only 100 rows, or 10 rows, a very small number of rows, it might decide to use a nested loops join, for example. But in reality, at runtime, it realizes there are 1 million rows. Oh, boy. It's not going to be so good. Okay? Maybe a hash match would be much better. So it's really important. Another thing, for example, is memory grants. During compile time, SQL Server needs to estimate how much memory it is going to need to run the query. And again, if it thinks that there is a table with only 10 rows, and there is a sort operator, how much memory do we need to sort 10 rows? Nothing. No big deal. So it's going to ask for nothing memory during compile time. It's going to be allocated nothing memory. And then at runtime, oops, I need to actually sort 1 million rows. I don't have enough memory. You're going to see spill to TempDB. Paging to disk, it's going to really slow up your query. Another thing could be, for example, the max DOP, max degree of parallelism. SQL Server needs to decide whether to run your query with a serial thread, a single thread, if it's low cost, because it has a small number of rows, or maybe it should use 8, 16, 32 threads, I don't know, and run this thing in parallel. Okay? And again, if it's going to make the wrong estimations, it's going to take the wrong decisions, you're going to suffer from poor performance. So those are just a few examples. There are many, many things that affect performance that rely on the estimated number of rows. And this is why it's very important to have good statistics, and I'll show you some best practices. And also, this is why when you look at execution plan, the most important thing to look for, again, are the gaps where SQL Server got things wrong, the gaps between the estimated number of rows and the actual number of rows. And the next thing I'm going to do here, almost done. I'm going to show you first the statistics on the table after creating the two indexes, because another thing you need to know is that whenever you create an index in SQL Server also creates statistics behind that index. Always. It doesn't really ask us if we want to do it or not. It's called index statistics. And it's the same statistics with the histogram and everything. It's just based on a full scan. Because SQL Server says, if I'm going to scan the entire table to create the index, and I'm going to sort the entire column to create the index anyway, I might as well use the opportunity to create a histogram, a very accurate, full scan histogram on that column. And it does that always. So if we look at the statistics now, in addition to the one we saw before, we have two additional statistics. Those are index statistics. This one is for the clustered index. This one is for the non-clustered index. And you can see that they are based on 100%, a full scan, as opposed to this one. So they are much more accurate. Okay? Of course, they take more time, but we don't care because we wanted to create the indexes anyway. And now we end up with two statistics on the same column. So what happens now? What SQL Server is going to do in the next query? Which one is it going to use? Unfortunately, SQL Server allows us to have multiple statistics on the same column, just like it allows us to have multiple indexes on the same column, which doesn't always make sense, but we can do that. Okay? So this is something you need to take into account. You need to do some maintenance once in a while and maybe delete statistics that you don't need, because SQL Server will continue to maintain them. Okay? In this case, we have two, and let's see what happens. Oh, I also want to compare between the two histograms. So this is the column stats, which is based on a small sample. This is the index stats, which is based on a full scan. And this is the deviation between them. So you can see that for some, let's say this one, self-help books. Okay, this is the estimated value based on the column statistics. This is the estimated, which is the correct value based on the full scan. Okay, so there is a gap. So I just want to demonstrate the accuracy based on the sample size, which means if we take children books, for example, which statistics SQL Server is going to use? This is the actual number, and as you can see, thankfully, it uses the statistics with a full scan, the index statistics. So SQL Server knows if it has multiple statistics, it will always choose the one with a higher accuracy, with a higher sample size. Okay, at least we have that. Great. Now, I don't want just to count. I want to return results. I want to return all of these columns based on the category. Remember, we have a non-clustered index, but it's a non-covering index. Okay, so we need to do lookups. I'm going back to the story on the library. Okay, and another tip I want to give you is this and this. It's going to return a lot of rows in all of the demos here. And when you troubleshoot performance of a query, and the query returns a lot of rows, like 1 million rows or something like that, it takes a lot of time for SQL Server to send the rows to the client, in this case SSMS, and also for the client to present the rows on screen in the grid. Okay? And you want to troubleshoot the server time, the plan, the execution plan, the time it takes for SQL Server to run the actual query at the server. You don't want to troubleshoot the time it takes for the network to give you the results. Okay? And this can be misleading. So if you're just going to do a select that returns the 1 million rows, it might take, I don't know, let's say 20 seconds. Out of the 20 seconds, 19 seconds is just sending the rows back to the client, okay? And you don't really know that. And then you do some improvement, which might be very, very meaningful but you don't see it because it still takes 19.5 seconds, because most of the time you spend sending rows to SQL Server. So a tip for you, if you want to do this, you want to make sure that you don't take into account the time to send the rows to the client. There are many ways to overcome this. One of them is just to send it into a dump table, a temporary table, and then drop it. Okay? Just one trick of many you can use. Okay? And then you don't need to send everything to SQL Server. It still has some additional overhead of inserting into a temporary table, but it's much, much, much less costly than sending it to the client. So in this case, I'm going to, again, look at all the classics. So it runs very fast. This is the number of rows. I'm only interested in the plan from now on, and only, again, in those numbers. This is what I'm going to look at from now on. Okay? So in this case, based on very accurate statistics, SQL Server could say, I know the exact number of rows. I'm going to use an index seek plus 8,000 key lookups. This is the best plan. And it is correct. This is great. This ends up with, where is it? 31,000 logical reads, data pages to read for this query. Okay? What happens when we ask for Romans? Remember, we have 5 million books. Okay, so we get this, very good, accurate estimation. And SQL Server says, OK, for this number, I'm going to use a different plan, a clustered index scan. Because if I'm going to do 5 million key lookups, it's going to take a lot of time. This ends up with this amount of logical reads, almost 800,000. And just to demonstrate, if I forced SQL Server to use the non-clustered index, now it's going for Romans for 5 million. Sorry, and with the drop table. It's going to take some more time, because now SQL Server is forced to do 5 million key lookups. And this is just an example of what would have happened if SQL Server got things wrong based on statistics. Okay? So it now needs to do 5 million key lookups. It ends up with this number of logical reads. A lot of I/O, wasted I/O. Okay? Now, what happens when SQL Server doesn't have access to the histogram? It can't use the histogram. There are all kinds of use cases where SQL Server can't use the histogram. One of them is when you use local variables, for example. I have a local variable called category with classics, and then I'm going to use the local variable here. So this one looks very innocent. It looks like the previous query. What's the difference? Okay, instead of putting the literal value here, I'm going to use a variable for that. That's great, isn't it? Well, not so great in terms of performance. Because what you should know that with local variables, remember we have compile time and then runtime. During compile time, SQL Server doesn't know the value of the local variable, the content of the local variable. It just doesn't. It is considered an unknown value. Okay? Only at runtime, we will run this command that sets its value. During compile time, we don't know it. So SQL Server now needs to estimate the number of rows for an unknown value. It can't use the histogram for that because it's unknown. What it does, remember that value? This one? The old density from the statistics? This is the average number of rows per distinct value, any value, in a table. So SQL Server says, OK, instead of just a wild guess, I can at least use that, the total average. But of course, again, this is a wild guess, OK? As you can see. It has nothing to do with the actual number of rows, and we got a poor plan in this case, OK? If SQL Server knew this is the number, it would use a non-clustered index plus key lookups in this case. So remember that about local variables. OK, now we can also create statistics ourselves, manually. In most cases, we don't need to because SQL Server will automatically create statistics. But in some cases, we want to create statistics ourselves. And when we do that, I can give it a name, my own name, of course. In this case, it's going to be on the publication date. We can specify the sample size. Now, usually we won't say 50 or 60. Usually it's either the default sample size of SQL Server or full scan. Sometimes you want to play with it. Just for the demo, I'm using 50%. And also, let me run it. It will take a few seconds. And also, this is important. This is something that was introduced in SQL Server 2016, persist sample percent. This means I'm currently creating statistics based on the 50% of the table. Okay? Now, SQL Server also has a mechanism to automatically update statistics. We talked about it. I will show you this later. when SQL Server automatically updates statistics, by default, it will use its own, again, sample size, okay, which is very small. It's going to ruin my more or less accurate statistics with 50% with something that is 0.7% or so, okay? I have the option to say, from now on, whenever you, SQL Server, update the statistics, please continue to persist my sample size. Continue to use 50%, okay? So this is the meaning of this property. It might be important sometimes. Let's look at statistics on the publication date, the new one. So now we see a little bit more interesting, more real statistics from real life, where it's not just 26 distinct values and that's it. We have lots of different publication dates. So now SQL Server doesn't just populate the equality rows, but also these values. What they mean, let's just take as an example this one, this date. So between these two values in the histogram, range rows gives me the number of rows between the two values, two consecutive values, the previous one and the current one. Okay, so this is again an estimation of the number of rows in the table between these two values, excluding the values themselves. Then we have the equality rows like before. So this is the number of rows in the table with this exact value. And we also have this, which is the number of distinct values in the same range. So we have the number of rows in this range. We have the number of distinct values in this range. And then we have this one, which is simply number of rows divided by the number of distinct rows. So this gives me the average number of rows per distinct value in this specific range. So SQL Server has a lot of information in this very compact data structure. So for every entry, it has the average number of rows for that distinct value. It also has the total average for the entire table, as we saw earlier. Okay, so this is what we get from the histogram. And then let's try something else. Until now, we did equality comparisons. Let's try inequality. What happens with that? So SQL Server can still, of course, use the histogram. I want to search for all the books with the publication date in the last 3 months, for example. So you don't have too many of them. So it's not 100%, but it's somewhere in the area, okay? So again, this value, 1,259, comes from the histogram. Based on all the values there, it tries to calculate, to estimate number of rows, even with inequality, which is not bad. But again, what happens if we use a local variable with an inequality operator, which means SQL Server doesn't know the value during compile time, and it can't use the histogram. Now, it also can't use the all density in this case because it's an inequality. It could be anything, okay? So what does SQL Server do in this case? Do you know? First of all, we got a very, very poor estimation, 1.2 million or 12 million? 12 million. Not too good, okay? Where does this number, 12 million, come from? So in this case, it's one of the rules of SQL Server. When you have an inequality operator with an unknown value, SQL Server always estimates 30% of the total rows. Always, hard-coded in SQL Server. And again, this is like a wild guess. Okay, so this is where it comes from, the 12 million estimation. Not so good. So make sure that you don't have those cases, a query with an unknown value, whether it's a local variable or something else. Okay, let's look at correlation between different columns. Okay, so for example, in our library, the average number of pages for children books is 20. The average number of pages for science books, it's almost 600. Okay, which maybe makes sense. I don't know. And this means there is a correlation between columns in this case. If we have a query that asks for the combination of all the children books with 20 pages, there are probably many, many books like that, okay? But if we look for science books with 20 pages, there are not so many, okay? Because there is a correlation. Now, depending on your data, your tables, sometimes there is a correlation between columns, sometimes there isn't. Sometimes the correlation is strong, sometimes it's not so strong. It also depends on the value themselves. And in this case, SQL Server needs to make all kinds of assumptions. It has a histogram of one column, a histogram of another column. It needs to combine them somehow using some assumptions about the correlation between them. So in this case, I want to talk about a very important aspect or component in SQL Server, which is the cardinality estimator. The cardinality estimator is a component within the optimizer that is responsible for estimating the number of rows. All of those estimated number of rows, this is the component responsible for that, come up with that value, okay? And Microsoft rewrote this component in SQL Server 2014. So if you're using today, is anyone using 2012, for example? Some of you. Okay, so in 2012 and before that, we have the old version, the legacy version, and starting with SQL Server 2014 and all newer versions, we have a new version, a completely new version of the cardinality estimator. It means new algorithms, different algorithms. They made all kinds of changes, okay? One of them, I'm going to demonstrate, is how SQL Server treats the correlation between columns. So just to demonstrate a few tactics in this case, we have the ability at the database level to go to the legacy cardinality estimator. Even though I'm using 2022, I want to use the legacy one. And let's look at the following query. Give me all the children books with 20 pages. Okay, so in the old cardinality estimator, SQL Server assumes no correlation between the columns. So it simply takes the probability of children books, the probability of 20 pages, multiplies them together. Okay, and then it comes up with an estimation, which is not so good. Okay. Only 1,645. And we can do the same for, I think I forgot to drop the table. Okay. We can do the same for science books with 600 number of pages. And again, not so good estimation because it just multiplies the probability. But we know there is a correlation there. So one of the changes, again, if we go back to the new cardinality estimator, we run the same one with science at 600, for example. So as you can see, we now have a much better estimation. We only change the algorithm, the version of the cardinality estimator, because now it takes into account a certain amount of correlation between columns. And in some cases, the new cardinality estimator will yield better results. In some cases, it will be the other way around. Okay? It really depends on the workload. Hopefully, and I can say from my experience, then yes, in most cases, the new estimator will perform better. But you still need to be aware of the correlation between your columns and your queries and troubleshoot where needed. Okay. Let's go back to the statistics. So of course, SQL Server created a new statistics automatically for the number of pages. We created one for the category, and now it uses both of them to correlate between them somehow. But another option, sometimes we can help SQL Server even better. We can do this. We can create a multi-column statistics on both category and number of pages. Now, this is something that SQL Server can't do automatically. It just can't. It never does that. SQL Server will never create automatically a multi-column statistics, always a single column. But we can. Okay? So sometimes, in some cases, we might help SQL Server by creating a multi-column statistics. If we do this, then when we do this, we don't really create a histogram for the two columns. There's no such thing. The histogram will always be only for the first column, in this case for the category. But we already have two histograms for the category. Yes, question?
If you create an index or multiple columns.
Same thing, exactly. If you create an index on multiple columns, or even the non-clustered index itself, which also has the clustered index key, it's like a multi-column index, it also creates a multi-column statistics behind the scenes. Okay, thanks for the question. But still, the histogram will always be only on the first column. What we do have for the combination of the two columns is the all density. Remember, we have the all density, the average number of rows per unique combination of category and number of pages. And this single number might be useful in some cases more than multiplying two histograms together, two statistics. Okay? Now, in most cases, it won't help. Okay? In most cases, it would be better for SQL Server to take two histograms and based on specific values in the histograms, combine them together somehow. But in some cases, this might help. This might yield better results. I want to show you. Again, it's the optimizer's choice to decide whether to use the multi-column statistics or not. Okay? It has a very sophisticated algorithm for that. Probably if in this demo, it will choose not to use the multi-column statistics. I want to show you the value itself. and then we run the same query to see if it uses it or not. Okay. Any questions while it's running? Oh, it's done. Okay. So, there's a question? Yes, yes, sorry.
What scenario would you choose to do the multi-column stats but not an index?
But not an index?
Yes. Why would you choose to do the stats?
That's a good question. The question was, why should I create a statistics and not an index, which also has statistics? So in most cases, yes, I would create an index because I also need the index for the plan itself, okay? But sometimes I don't need the index itself. I just want SQL Server to be able to estimate correctly for other purposes like doing an aggregate or things like that. I not always need the index, but in most cases, yes, I do.
Just love to try it and see when you're running your queries.
Yeah, in a way, yeah.
Well, but then it works well, but you don't need an index, then you do.
Exactly. Okay, thank you. All right, so let's look at the multi-column statistics. So again, the histogram is still only on the category, the first column, but we have all density value for the category itself, but also this value for the combination of the two of them, okay? Now again, we can take this value, multiply by the number of rows, we get the all density. Let's keep that, let's just see what SQL Server decided to do. And you will see it's still the same estimation as before. It didn't use the multi-column statistics in this case. Sometimes it will. You need to play with it and see when it fits. Okay, but another very important tool I want you to be familiar with is filtered statistics. And again, you can create filtered indexes, which makes sense in many cases. SQL Server will also create filtered statistics behind the scenes, okay, the same logic. But you can also create filtered statistics by itself, okay, like this. Create statistics. In this case, statistics is on the number of pages. So we have a histogram on the number of pages, but only for children books, for example. So this means statistics is based on a small subset of the table, only children books, and we get a much more accurate histogram on that subset of the table. And it also takes much less time to create and update the statistics, okay? Because it's not 40 million rows, so we can use full scan. So this will run very quickly. And now, children with 20 pages, look at this. Boom. Okay, so yes, question.
Create a filtered index. Would it create statistics using a full scan or a sample?
Yeah, so the question is, if I create a filtered index, will it create a filtered statistics with a full scan or a sample? So when you create an index, any index, filtered or not, it will always create a full scan statistics, okay? Because it needs to full scan. And again, it's a full scan of the filter, okay? After the filter, of course, okay? Yes?
Having a formalized index compared to creating statistics, what's overhead on email operations? In some things, deletes would they be more efficient working with statistics only, or how to update formalized index?
If you then have updates, deletes, how they affect index of statistics?
Is it less of a overhead?
Yes, yes, of course. So the question is, if we have, of course, DML statements, insert, update, delete, what is the difference between creating an index or only statistics, right? What is the MPIC, the overhead? So of course, when you have a lot of DML statements, there is a lot of impact on indexes, because SQL Server must maintain the indexes online. So if you do an insert, for example, it needs to insert the new values into all the indexes on the table. If you have lots of indexes, that might be a problem, okay? With statistics, it doesn't do anything. It updates statistics asynchronously. Once in a while, I will show that later, okay? But during the DML statements, nothing happens to statistics. They stay the same, okay? All right, so remember filtered statistics? It's a very powerful tool. There are all kinds of use cases for filtered statistics. I think that people are not aware of that. They're not familiar enough with the power of filtered statistics. This was just a small example, of course. And if we look at the statistics again, then now we have the filtered statistics. And I want to show you, I also have the unfiltered rows and the number of rows. So this is the entire number of rows in the table. This is the number of rows that this specific statistics is based on after the filter, okay? And this is, so this one. This one is the actual sample size, which is in this case full scan because it's an index statistics, okay? Sorry, it's not an index statistics. I did it with the full scan. My mistake. Okay. Now, let's talk about updates. SQL Server also has a mechanism to automatically update statistics, and it's important. Unlike indexes, it doesn't update statistics all the time online. Okay? It does this once in a while. It has a modification counter. It counts the number of rows affected in a specific column, and when it crosses the threshold, it will trigger an automatic update for that statistics. Now, what is that threshold? If you're using a version of SQL Server before 2016, 2014 or earlier, the threshold is 20%. Okay, with a slight 20%. Let's call it 20%. So 20% of the table. If we have 40 million, 20% is 8 million, right? So you need to wait until 8 million rows are modified or inserted or deleted before the next update statistics. This might take a while. Starting with SQL Server 2016, it's a different threshold. It's this. You take the count of the table, multiply it by 1,000, take the square root. This is the formula used by SQL Server. In our case, it's like 200,000 rows, more or less. Okay? So after 200,000 rows, not 8 million, SQL Server will trigger an auto-update statistics. So let's test it. Let's update 200,000 rows. I don't care which. We'll just update the publication date to now. Let's look at statistics again. So now, the modification counter is already 200,000 only for the publication date statistics, because this is the only column I modified. Okay? And it's important to know that SQL Server will automatically update statistics, not when it crosses the threshold, but in the next query. The next query that comes along, during compilation time, it says, oh, I need to update statistics, let's do it now, and then generate a new plan. Okay? So let's run a query, the same one with the last 3 months. And we can see that, of course, now we have, now we have a lot more values in the last 3 months, but statistics is not updated yet, because we only updated 200,000. We need 200,003 or something like that. Okay? So it's not updated yet. So let's update another 5,000 rows. This will cross the threshold. Let's look at statistics again. So it's now this. And now, when I run the next query, it will take some time. Remember, I created the statistics on the publication date myself with a sample of 50%, and I said persist sample percent. This is the implication of that. So now SQL Server needs to automatically update, but it persists my 50%. It will take time, and this time is during the compilation time of some user trying to run the query. This might be a problem. Okay? And it can trigger any time during the day. We don't have control of when this is going to happen, when it's going to cross the threshold. But now, as you can see, we have a new statistics already. It's updated. We got much better results. And if we look at the statistics, then first we can see that the updated time is now. It was updated. And this is reset to 0, and we start all over again. Okay, so this is the mechanism for automatically update. And it's not, well, I guess in many cases, simple production workloads, leaving the auto-update statistics as it is good enough. Don't do anything, it's good, it's okay. But for many other workloads, where you care about performance and it's like mission critical and very heavy, this might be a problem. Because you don't have control of when it's going to happen and the size of the sample it is going to use. Okay? And in many cases, I want to take control. Okay? So my recommendation to you is implement your own substitute for maintaining statistics. Okay? Something that runs with your own schedule. You control the schedule. You control the logic, when to update statistics, which statistics to update, which sample size to use, and so on and so on. Test it. Once it's working, turn out to update statistics to off, to false. Okay? But it's risky, okay? You need to very well test it, make sure that it works properly. And just to demonstrate, I can run this command manually with all kinds of properties, and I can say, I want to update statistics now with a full scan, for example, okay? But I decide when and how. Yes? Sorry, can you come back again? Yeah, it's like a one-time, during a specific execution, something went wrong because it now needs to update statistics. You can monitor it, of course. Using scan events or Profiler, you can have events of how to update stats and see exactly when it happens. But again, my recommendation would be to disable it altogether and control when and how to do it yourself. Okay? I just have a few minutes. I want to go through the summary slides because I have a few. And then I will leave time for questions. So, a few things regarding versions of SQL Server. Okay? If you are using 2012 and you are going to upgrade, in 2014, I talked about that. We have the new cardinality estimator. So this is very important to understand. Another thing I didn't talk about is incremental statistics. If you have very large tables and they are partitioned, you can enable incremental statistics for partitioned tables. This means the SQL Server will update statistics per partition. And it will take a lot less time. It will be a lot more accurate. And you don't really need to update statistics for a table that holds 7 years of data. Nothing changes, right? Only the last day or the last week. So you can only update statistics for the last day of the last week with full scan because it's nothing. Okay, so it works much, much better with incremental statistics for partition tables. It's not enabled by default. So make sure that you enable it and test. In SQL Server 2016, we have the new auto-update statistics, 1,000 multiplied by the count square root, remember? Before 2016, by the way, people that use SQL Server 2014 or 12, you can use trace flag 2371 to get the same behavior. Okay, and this is like a best practice. It's recommended, but please test it. We also introduced the persistent sample percent, like I said before. I jumped to SQL Server 2022. There are lots of great features in other versions, but not related to statistics. In 2022, there is a very interesting new feature called cardinality estimation feedback. SQL Server uses query store to track the cardinality estimates, the estimated number of rows compared to the actual number of rows. And after a while, it says, OK, I got things wrong. I will try to automatically fix it. And then at some point, it will recompile and try a different algorithm to come up with a better cardinality estimate. It does that automatically in 2022. It's a very cool feature. And some takeaways. I know I'm late, sorry. So first thing, when you troubleshoot execution plans, look for the gaps between the estimated and actual number of rows. Very important, okay? The second thing, if you upgrade from something before 2014, be very careful because I saw a lot of customers fall when they upgrade to the new cardinality estimator. It might affect your query plans in all kinds of ways. You need to be careful, monitor, do it slowly, okay? Remember that. Use trace flag 2371 before 2016. I talked about that. Avoid using local variables. There are all kinds of ways to overcome the problem with them, like using parameters or dynamic SQL or option recompile, stuff like that. Don't just use local variables and expect good performance, okay? Because, well, incremental statistics for partition tables, but don't forget to test. In some cases, multi-column statistics will be helpful, but in many cases, filter statistics could be helpful. Remember that, okay? You need to investigate filter statistics more. Don't trust, in many cases, don't trust the auto-update statistics mechanism. Replace it with something of your own, but test, test, test. And thank you very much.